Hello and welcome to another C++ tutorial. So this time around we are going to be taking a look at the area of memory allocation, which is something that in C++ we have a lot more control over and that we have to actually take a lot more responsibility for, particularly if you're coming from the C# side of things. There's a lot more things that we need to remember to do in C++ when we're working with memory. So let's dive on in and take a look. So what we're going to start with is initially actually seeing how do we go about allocating memory. So we're going to see this where we'll be using a lot of pointers. That's pretty standard. So, okay, if I want to allocate memory, so int pointer, I can say, well, that's a new integer. I could give that a value, so 53, and then I could output the value of that. Then I actually output two different things. Now we have seen before with pointers value and reference types, the difference between referencing and so forth. So we know that this is accessing the particular value stored at that location in memory. Same for this, it's accessing the value stored at that location in memory. But I'm actually going to output the memory location itself as well, just so we can see that these are actually different. And then when I'm done with the memory, I'm going to do delete. This is something that in C# we don't need to worry about. It actually cleans up the memory for us. Whereas in C++, that doesn't happen. We have to actually manually clean it up. Otherwise, something called memory leaks happens. And I'll show you what that actually looks like and the processes of that in a moment. Firstly, just want to see what happens with this. So we can see, here's the memory location, and then here is the actual value. So we were able to allocate memory and we were able to free it. But if I don't delete it, then what will happen is a memory leak. So what that means is we've allocated memory, but then that doesn't get cleaned up. Now, modern operating systems are pretty clever, and when an application closes, they will still be able to clean up all of the memory associated with it. However, say you have a for loop or a block of code that's running consistently, and that block of code has a memory leak in it. Over time, your application can end up leaking very, very large amounts of memory, which means the memory usage of your application can grow quite large. And then in particular on something like a mobile device, there are points where once it hits a certain memory allocation, the operating system will actually just kill your application because it's using too much memory. Even on desktop operating systems, there will reach a point where you will not be able to allocate any further memory. So memory leaks are something we want to avoid. We do not want to have memory leaks. That's why in engines like Unreal, there's a lot of infrastructure there to provide garbage collection and specific processes for how you allocate memory to ensure that actually Unreal can keep track of it and can make it easier for you tracking down those leaks. So Visual Studio, and what I'm going to show you is very specific to Visual Studio. There are a couple of things we can do for being able to track memory leaks. So what I can do, and I'll actually put a link to where this is sourced from here. So there's a couple of header files we include. There's an additional define we add. Now this is going to slow down the program, which in something this size and scale, not a big deal, but in a larger one, definitely a factor, which is why you want to try and have good practices to prevent memory leaks. It's why, again, Unreal has a lot of infrastructure around how you actually work with memory so that you don't need to go and run the manual detection of memory leaks because it slows down everything. then all we do is at the end of the program, we put this. So those are the two parts we need to add. So now if I run this, then you'll notice here in the output, we get that there was a memory leak. So it detected memory leaks, and if I re-enable that, no output indicating that there's memory leak happened. So this is really important. We need to make sure that any new is paired with a corresponding delete so that we don't end up leaking memory. It's very, very easy to have happen. And again, this is why we have specific structures and things like that in Unreal and everything for making sure that we don't leak memory. So, okay, that's good. What if I wanted to work with an array though? Because this is a single integer. So what if I wanted to have an array? So what I'm going to do is I'm going to just put all of this in braces. And we'll do another one here where, okay, let's have int star int pointer is new int, and let's say 50. And let's set one of those values. Now the way we access this is slightly differently now because we're working with an array. 42. We're going to output that value just to make sure that it is working correctly. And I'm going to actually rename this to integer array. That's good. And then down here, I'm just going to do delete int array. And let's see what happens. So I'll run it. Output the correct value there. That's good. Let's do the quick run so we should get any notification of memory leaks. So we're not getting any notification of memory leaks, so that's good. However, you'll notice that it's giving us a warning here. So when we're using our new for an array, we do need to make sure we use the array delete. It didn't report any memory leaks, but it is something where you can get issues like memory leaks happening with it, because otherwise it doesn't have a lot of information to tell the difference between these two. An int pointer and an integer array, these are exactly the same. So unless it knows that it's working with an array, you can run into issues there. So really important to make sure that we use the correct delete. Visual Studio did warn us in this case, but as we saw, it didn't show up as a memory leak. So okay, we've seen for allocating simple things here like this. What about when we get to having our own classes, and what if that class allocates things? So let's have simple class A. And what I'm going to do is it's going to have and good practice also when you're working with these pointers till it's allocated, set it to null PTR. Null in all uppercase used to be the one that was used, but null PTR is actually the preferred one. You'll get better type checking and errors and things like that with it. So what I'm going to do is, okay, in simple class A, I'm going to do int pointer is new int, and then we'll give it a value. Even makes that public as well. So then down here, what I'm going to do is simple class A. So let's try one way of working with it. Variable 1. And let's just do that and see what happens. So I'm not even going to try and output anything. I'm just going to have it created. So let's run it. So we can see it's leaked memory. Well, okay. Maybe if I declared it as a pointer. So maybe if I did simple class A, variable pointer 1, new of that, and then if I delete it afterwards, maybe then it's fine. Well, actually now I've got two things leaking, so it's leaking memory in both cases. So that's because classes, as well as them supporting a constructor, something that in C++ they support is also a destructor. So what a destructor looks like is this. Simple class A. So destructors are always parameterless. They never have a parameter to them. And it is just the name of the class and the tilde before it. So what I can do in this case is I can go delete int pointer. So this is the purpose of a destructor, is for doing any cleanup like of that. So if I run it, we'll notice the memory leaks that it was reporting, those are all gone. So okay, that's pretty cool. We can see how with a class we can do a cleanup of things if we need to. What if we had one class that inherited from this? So simple class B. And publicly inherit from that. And then I'm not going to add too much to this. I'm going to actually initially just have it like this. And we'll just see what happens in this case. So we'll go for exactly the same as what we had here. We're just wanting to be using B. So we're going to just test initially with that. So, okay, everything runs. No memory leaks. That's all looking good so far. Well, let's give it its own version of this stuff. So I'm going to call this int pointer 2 to do the same here. So it's going to be cleaning up its memory. So it wasn't leaking memory before. All we've done now is we've added in this. So, okay, let it run. And so far, that's looking all good. Not seeing any issues being reported there. So we're not seeing it report any issues there, but has it actually gone and done everything it needed to? So simple class B hasn't actually run the constructor for simple class A. So let's let it run that, and now let's test it. So far so good. We're not seeing any issues reported there. It's managing to do all of the logic. Let's check, is it actually running the destructor for this though? And we can also chuck in one here for saying that it's running that for B. We'll also, just because it would be handy to know that it's running the constructor, put in an indicator of that. Same thing here. So, okay, let's test this out, see what we get output-wise. So, we can see if we run this, the destructors, everything like that is all being called exactly as we would expect it to. You know, constructor of A happens, then the constructor of B, and then when it's destructing, it destructs B, then A. So everything actually looks like it's completely working, like there's no problem. But in the scenario of inheritance, we often wouldn't be storing it as a pointer to itself. We'd often be doing this. So what happens now? So if I run it, we can see destructs A, then destructs B. That's from the first case. Then we have a scenario where it destructs A, but the destructor of B doesn't get called. And if we look, there is a memory leak. So when we're working with inheritance, it's really important that with the destructors, we actually should mark them as virtual. So just like how a function can be marked as virtual, destructors can be marked as virtual as well. And if I run this now, memory leak is gone, and we see it correctly runs the right destructors. So it's a really easy one to miss because, as we saw, a lot of the ways we were writing the code, we didn't see the error. It wasn't until we started properly taking advantage of polymorphism that the error occurred. This is also the reason why most of the variable types containers in the standard template library, the STL, are not intended for you to actually inherit from them, and it's not safe for you to inherit from them. Things like standard strings, standard vector, those don't typically have virtual destructors, which means that memory is not going to get cleaned up properly unless you are very, very, very careful with how you're working with them. So that's why it's generally considered not good practice to inherit from things that are those base types in the STL. And you should check before you use one of them, does it have a virtual destructor? So okay, we've seen our key things. So just to recap, we have when we are allocating an individual item. So allocating individual item. So we must delete so that we free up memory. It's also good practice at that point to then set that pointer to null PTR. The reason being is I can actually just go and do a delete on something that is null and it'll be fine. I won't get any errors. It's not a problem. Delete safely handles that. But if I didn't set it to null, and I instead went and deleted it again, well, now we actually get a problem. We get an exception because it's tried to go and delete that same block of memory multiple times. So it's good practice to set to null after deletion or when it's actually not been assigned any value at all. So good practice to set to null PTR. So I recommend always with pointers giving them that initial value. If you're not immediately allocating them or setting them to something, set them to null PTR. As soon as you've deleted them, also then go and set them to null PTR. So allocating an array must use array delete. Again, with this, I can go int array is null PTR. So we can also do the same thing with classes. So here we go and set this to null PTR. We'll do the same down here. But the important thing with the classes is must have a destructor to free up memory that we allocated. And it must be virtual if we want to support inheritance. And in particular, if we want to support inheritance safely. If we don't want to support inheritance safely, then by all means have it not virtual. Or we might specifically not want it to be inherited from. But if we are going to intend for the class to be inherited, and we are going to be using polymorphism, it should be virtual. Now in a case like of this, I wouldn't strictly need to set this to null PTR because I know the entire class is being destroyed. So this would be the one exception where I wouldn't worry about setting it to null PTR. You still could, but it's not necessary in a case like of this. So those are the main things to remember. If you're allocating memory, make sure you free it. If you want to track down those memory leaks and you're using like a Visual Studio, then we have handy little things we can add in, and we just at the very end of our program tell it to dump out the memory leaks. Now that won't catch everything. There are things it will miss. Stuff like the array delete, it will miss. So there are some things that do get a little bit missed with it, but it is still a handy way of tracking down a lot of particular ones. And as I said, when we're working with classes, and in particular when we have polymorphism, we want to make sure that we have virtual destructors. So it is a little bit more wrangling to do in C++ when we're working with memory. There's a lot of stuff that we don't get for free. However, there are, just like how C# works with the garbage collection and things like that, there are systems and processes that we can wrap around this memory allocation to give the effect of what we have in C#, where when something's no longer being used, it gets its memory freed up. So there are data structures like of that we can work with, and those are things that I'll take a look at another point in time, because they can get quite complicated quite quickly, but can be a handy way of working with things. If you do want to look into those in advance, the thing's referred to as a shared pointer. So the idea behind a shared pointer is it knows how many things are referring to it, and as soon as something is no longer referring to it, so as soon as that reference count goes down to 0, it frees up the memory automatically. So you end up not needing to manually write the delete because it's keeping track of it for you. They do enforce some restrictions in terms of how you need to work with them, but they can be really, really handy. So that's the key stuff with working with memory in C++. Watch out for memory leaks. Make sure that news are paired with deletes. Make sure after we delete, we set things to null PTR. And with a pointer, if we're not initially allocating or assigning it to something, we should set it to null PTR because that's something that you can safely delete without causing any issues. So dive on in and experiment with this. Memory allocation is an area where there's a good chance of you being able to find creative and interesting ways to break things and to cause a whole bunch of errors. That's kind of the point. So we want to get those errors happening so that we learn how to identify them, how to fix them. And there is nothing like the combination of pointers and memory allocation and also classes to really cause lots and lots of errors. So dive on in and experiment with that. See the kinds of errors you can create. I guarantee you can create some very creative ones, but do dive in and experiment with that. Thanks folks, hope you found the video interesting and helpful. If you have, check out a like and subscribe, it really helps out, it's really appreciated. If you had any questions, then chuck in a comment below. If you're looking for the code for the project, the code is available up on GitHub, and there is a link to that in the description below. If you're trying to track down other videos, do have a searchable video archive, which I've put a link to that in the description as well. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description also. But until next time, bye.